This framework, we're going to dig in. We're going to look at volume to start off. We're going to be volume of all sorts of different types of solids. In this lesson, specifically, we're going to look at prisms and cylinders. So a prism, a right prism is what we're going to look at first, and a right cylinder just means that it's perpendicular to the base. It's got right angles. If you look up from the ground, the base of it, the sides all form right angles. That's why it's called a right prism or a right cylinder. So a prism just has any polygon you want on the base. So this one appears to be either a rectangle or a square. The base has got the same on the bottom as it does on the top, and then the sides are just rectangles. A cylinder is very similar. It's just the base, rather than being a polygon, it's a circle. So you have a circle for the base, bottom and top, which just makes one rectangle that would wrap around the whole thing. So volume formulas for these things. The prism, you can kind of just think of it as a box. Might be a weird shaped box, but it's still a box. Length times width times height. Volume is length times width times height. And if it's a cube, the length, width, and height are all the same thing, so that's why they just say S cubed. Now, a little bit more general, that was kind of specific to a rectangular prism. A little more general, no matter what the base is, if you find the area of that base times the height, that will be the volume of the prism. So it's the area of the base times the height. So no matter what the base is, if you find the area of it, if it's a triangle, find the area of the triangle times the height, that will give you the volume of the prism. One of the things you can kind of just think about for a prism, whatever the base is, if you had a whole bunch of that same shape and you stacked it up, you're going to get a prism. So here we've got the base as a rectangle. If you had a whole bunch of rectangles and stacked them on top of each other, it would be a prism. For a cylinder, going back to that real quick, if you had a whole bunch of circles, a whole bunch of discs, and stack them up, you get a cylinder. If you've ever seen a roll of quarters or whatever, that's basically how you get a cylinder. You stack up quarter on top of quarter on top of quarter. Although they're kind of flat to begin with, stack up a bunch of them, you get the height, and that's a cylinder. So you can, finding volume is pretty easy. You normally learn that in 8th grade or something. We're going to kick it up a little bit and use some conversions within it to solve real world problems. So here we've got a rectangular prism water tank with all the dimensions. We're going to find the volume of the water tank, and then we're going to figure out how much water is in it using the conversion that 1 gallon is 0.134 cubic feet. So find the volume first. Length times width times height. 60 times 8 times 120. Now it'd be feet cubed. So to answer the question then, 1 gallon is 0.134 feet cubed. So whenever you're doing a conversion, the easiest thing to do is put it as a fraction. And then next to it, you're going to write the conversion as a fraction. Since we have feet cubed in the top of our first fraction, we need feet cubed in the bottom of our next fraction so that they can cancel. So we're going to put the 0.134 cubic feet in the bottom and the 1 gallon up top. By doing that, cubic feet cancels cubic feet. That's what you want out of a conversion. You have 1 in the denominator and 1 in the numerator, they cancel out. So that means to do this conversion, we're going to take our 57,600 divided by 0.134. And that will be how many gallons this tank holds, which is 429,850.7463 gallons. It doesn't tell us where to round, so I'll just leave it there. It would make sense to round up to the nearest gallon, though. 429,851 gallons. So here we're going to find the volume of water once this ice cube melts. It says ice takes up more volume than water. So when it melts, it's going to be a little bit less. So whatever the volume is here, the water will be a little bit less. So we can first find the volume of this ice cube. It is a cube, so it's 3 by 3 by 3. 27 cubic centimeters. So if we use this density of ice as our conversion factor, we have centimeters cubed on top in the numerator. And this one says, this gets a little bit tricky, so I'm going to rewrite this density of ice. Since we've got a fraction here, that centimeters cubed is already in the denominator. It's really written out this way. With these conversion factors, these conversion fractions, you can either keep them the way that they are, or you can flip them. Since we have 27 cubic centimeters is in the numerator, we want it to be in the denominator when we convert. We're going to keep it the way it is because it's in the denominator. So by doing that, cubic centimeters cancels out. So we have 27 times 0.9167. This is for the ice. We have 24.7509 grams of the ice. So now we want to know how much water will be left after that. Since that's how many grams we have, we're going to convert it back now using the other conversion factor. And now we have 24.7509. Oops. over 1, we're going to use this conversion factor, which is 1 gram over 1 cubic centimeter. Now, I'm just going to go through it to be a little bit thorough and practice what we need to do for our conversions, because 1 over 1 doesn't really change anything. But since we have grams up top, we need grams in the denominator, which means we need the 1 cubic centimeter in the numerator. So that way grams cancel out. Now, the math wouldn't really change anything. Times 1 is still 24.7509 cubic centimeters. So we started with 27 cubic centimeters for the ice, but as it melted, it turned back into water. It's a little bit less than 25 cubic centimeters. So it's like it shrunk. You've probably experienced that if you've ever frozen a can of soda. The soda inside, the liquid inside expands when it freezes. Usually causes a big mess because it busts through the can. Things expand when they freeze. Liquid expands. So to find the volume of these figures, if we are told that this is 8 cubic units in 1 block, figure out how many blocks there are. 4, 5, 6, 7, 11. There are 11 blocks in that figure, and every block is 8 cubic units. That's really a conversion factor right there. This is saying 1 block equals 8 cubic units. 1 block, or 1 cube, or whatever you want to call it, is 8 units cubed. And here we have 11 blocks. We're trying to get rid of blocks and turn it into our units. We have blocks on top. We need to flip our conversion factor so that it will cancel out blocks. Blocks is on top. We need blocks in the bottom. So you'd multiply that, the blocks cancel, 11 times 8, you get 88 cubic units. U cubed. Similar question over here. We have 1, 2, 3, 4, 9 blocks. But we're told each side is 2K. So it's a cube, so it's 2K times 2K times 2K. Two times 2 times 2 is 8, and then K 3 times, K cubed. And that's the volume. So this is 1 block. So in our counting how many blocks are in the figure, there's 9 blocks. Blocks is in the numerator, so we need the 1 block in the denominator, so it cancels. Which means we put 8K cubed in the numerator. Nine times 8, 72, K to the third. So in those previous examples, all we talked about was right prisms and right cylinders. They can also be oblique, which just means they're slanted. So when you measure the height, the only thing that changes is you measure the height straight up. Don't worry about what the slanted side is or anything like that. You just measure the height straight up, perpendicular height. And kind of interesting thing is that height, even though the figure is slanted, it ends up being the same volume. So if you ever go back to the stack of quarters example I was talking about, you slightly, gently push it over, not so it tips, but all the quarters just get skewed like this, it would look like an oblique cylinder, but the number of quarters didn't change. The height doesn't change, the number of quarters doesn't change, it's got the same volume, it's just slanted. So the height just needs to be measured straight up. So what I was just briefly discussing there for a moment, called Cavaliers Principle, kind of a famous concept. If the cross sections are the same at every level for two figures, so if you take the cross section, you get a square and a square, no matter if this thing is tilted, slanted, whatever. If the cross sections are the same, the cross-sectional area, and the same height, then it's the same volume. So those are the three most important sections of this. They have to have the same volume. Two figures must have the same height and the same cross-sectional area at every level. So whether those cross-sections are squares or rectangles, they have the same area and there's the same height, so the same number of those stack up, the area will be the same. Here's a good example going back to the quarters that I was talking about. If you stack up 10 quarters so that it's a right cylinder, it'll look like that. If you slightly askew them so that it's tilted a little bit, still has the same volume because all those cross sections are the same. Still the same number of quarters, still the same height. So it will have the same volume. So same volume if it has the same height and the same cross-sectional area. So here's a cylinder. Find the volume of the oblique cylinder. And then use Cavaliers Principle to find the volume of a comparable right cylinder or prism. So we know the area of the base. We need the height. It's this area of the base times height. So the height of this oblique cylinder is 3 times that of its radius. So now I guess we need to know the radius, so we can multiply it by 3. If the area is 81 pi, and the formula for area, since that's a circle, is pi times radius squared, we can figure out the radius because we have an equation here. Pi cancels pi, which means r squared is 81, which means the radius is 9. And then we know that the height is 3 times the radius. So if the radius is 9, that means the height is 9 times 3, which is 27. So the volume, which is the area of the base times the height, the area of the base is 81 pi. and the height we just found was 27. It says round to the nearest tenth, so we will use 3.14 for pi. To the nearest tenth, that would round to 0.2. And the last little part of the directions here said, yes, we found the volume. Use Cavaliers Principle to find the volume of a comparable right cylinder or prism. Well, if it was comparable, it would have the same height, the same base, so it would have the same volume. Same idea here, we need to know the height. We already know the area of the base. Says it is a square base. So the area of a square is length times width, or in this case, they're the same thing. We have side length squared, which is the area of a square. In this case, it equals 75. So that means our side length is the square root of 75. You could rewrite it as 5 squared of 3. Which means the height, we're told, is 4 times that of the side length. So the height is 4 times square root of 75, or 5 squared of 3. So multiply that by 4, you get 20 squared of 3. That's our height. So the area of the base times the height. Area of the base is 75. Times the height is 20 square root of 3. And if you multiply by the square root of 3 to get to the nearest tenth in your calculator, you get about 2,598.1. To find the volume, you need the area of the base times the height. Our base is a circle with radius 12. The height's 45. So if the radius is 12, we need the area of that circle. Pi times radius squared. So that's the area of the base. Times the height is volume. So times 45. So 144 times 3.14 times 45 cubic inches. Number 7 is a little weird just because they throw in x's just to practice some algebra. You need the area of the base, which would be, let's have a right angle right there. So it's 4x times 5x is the area of the base. That's 20, 4 times 5. X times x is x squared. Volume is the area of the base times the height. So the area of the base right there times the height, which we're told is x plus 2. Multiply that out, and that's our volume. So for our algebra, we're going to distribute and then 20x squared times 2 is 40x squared. And those were centimeters, so that's centimeters cubed.